Welcome to Section 1, Review ACDC Superimposed Circuit. Okay, so here is our circuit, and we can see that we've got a DC supply of 10 volts. We've got a resistor network. We've got an AC supply also, which is capacitively coupled through C1 to the DC circuit. And then we've got a C2 filter cap across the output. All right, so the first thing we want to do in this circuit is to do our DC analysis and find out all the different DC voltages and specifically the output DC voltage. And we're going to do that by doing a redraw. I'm just going to redraw the circuit here, and we've got our 10 volts in series with R1. And then in series with R2. And we know our V out is right here. And so we don't even need to include RG or the capacitors because we know that at DC the capacitors act like an open. Okay, so now that we've got our DC all figured out, let's go ahead and do an AC redraw. And we're going to redraw this at midband. So at midband, the coupling cap C1 should be doing its job and acting like a short, and the filter cap at midband should be acting like an open. So we can redraw our AC circuit like this. We also need to remember that for an AC circuit, the DC supply looks like an AC ground. So we've actually got R1 right here in parallel with R2. And then our V out is located right here. So we can find all those AC voltages. So now that we have our DC and our AC voltages calculated at midband, we know that the AC signal is going to be superimposed on the DC. So if we've got a DC voltage, let's say we get 0 volts right here, we've got some VDC here that we calculated. The AC signal is going to be superimposed or ride right on that DC. The center part of the AC is going to be right through that DC. So we've got our 0 volts down here. Our waveform is going to be offset by that DC that's present at the circuit. Pass side of the pass band. Right here, this F cutoff is going to be impacted by C1. So at that frequency, we know that C2 should be acting like an open at the midband. So we know that this frequency should be even less than that. So C2 should be acting as an open. So if we want to do R Thevenin for C1, we should get a formula that looks like this. We've got RG plus 2K, the RS, plus R1 in parallel with R2. And we know, so if we find R Thevenin, now we know what C is equal to, so we know that FC low should be equal to 1 divided by 2 pi R Thevenin C1 times C1. right? So now we've got all the DC, the AC, we've got the low frequency voltages and or response, and now we want to find the high frequency cutoff. So we're talking right here, and we know that that's going to be impacted by C2. We know that at this frequency, C1 has been shorted for a long time, so it should have been shorted. It is shorted in the midband. So our redraw, or our Thevenin C2, would look like this. It's equal to R1 in parallel with R2 in parallel with the quantity Rs plus Rg. Now we can solve for Fc high. It's equal to 1 divided by 2 pi R Thevenin C2 times C2. And that should give us our Fc high. So finally, our AC at the cutoff frequency, our AC is still going to be superimposed on the DC voltage. However, at the cutoff frequency, our amplitude is going to be 0.707 of the midband voltage. So our V out or VAC voltage, V out at the cutoff, Fc high and Fc low will be equal to 0.707 multiplied by the midband V peak.